Hey everyone, welcome back to my full stack banking app presentation. My name is Nick. This is going to be part 2 of a 3-part video presentation. So if you haven't already, make sure you watch part 1. I basically laid out all the front-end architecture, the authentication methods that I used, as well as a app diagram that basically lays out visually at least all the relationships between each component and all that. So it was a quick video, but yeah, if you want to get caught up with this one, make sure you watch that one. As far as this video though, we're going to be covering the database and the API that I used when developing this program. So before I get into any specifics about MongoDB, which is the database I used, I'm just going to kind of explain what it is and some of its features before I explain how I implemented it into my project. And yeah, let's get right into it. So like I said, I did use MongoDB to control my database. It just makes it very simple, very easy to have a collection of data, and it manages it very well. I chose MongoDB due to its flexible nature and capability to expand as the data load increases. So one of the great features of MongoDB is its storage method. It utilizes a format known as BSON, which closely resembles JSON. What this format does is it enables the storage and management of connected data structures in a way that's convenient and straightforward. So in the MongoDB database, information is structured into collections, functioning a lot like tables in traditional databases. These collections act as containers for multiple documents, with each document representing an individual data entry formatted using BSON. The database's architecture is designed to meet the specific demands of the application. With each document nestled within these collections contains a comprehensive set of fields tailored to capture and define the unique properties and attributes of the corresponding entity it represents. That's a mouthful. All the user accounts are persistent and stored in the MongoDB database. So that's what I use the MongoDB database for, to make sure that I have their user information stored and that it persists across logins. So basically what that means is once a user logs in, if they make a deposit or any type of transaction that shows up on the all data screen, regardless of if they log out and someone else logs in, that information persists. So it stays there regardless of if they log out or not. So it stays. We're basically storing that information. So the DAO was used to add new accounts, authenticate users at login, and display the list of all accounts stored in the database. So now let's talk about the API. So what exactly is an API? An API is an application programming interface. It's basically a set of protocols that allows different software applications to communicate and interact with each other. It defines the methods and data formats that applications can use to request and exchange information. APIs enable developers to access specific features or data from a service or application without needing to understand how that service or application is implemented. Think of it as a messenger that helps different software programs talk to each other. Or a waiter taking your order in a restaurant and then bringing that order to the kitchen where your order is prepared. To put it simply, it's a set of protocols that allows different apps to communicate with each other. The API that I use specifically is called a RESTful API. The endpoints to access the account database are located at the /records file. What they do is they get, put, and make, let me rephrase that. They make, get, put, and delete requests, and that you can find it in the records file. What they do is they retrieve, update, or delete the account associated with the ID. And right here you can actually see those get and put requests. More specifically, the get request being made. It's going to be that router.get function there. API endpoints refer to the accessible URLs provided by the server. designed to manage and respond to incoming requests from the front end. Each endpoint is associated with a particular action or functionality that the API is capable of executing. And so right here, these are what my GET requests are actually doing, or what the actual GET function is doing. This route responds to GET request made to the root URL. It accesses a collection named accounts from a database. It uses the find method on the accounts collection to retrieve all documents or entries in that collection. The retrieved documents are converted into an array using the toArray and stored in the results variable. Finally, it sends back the results array as a response with a status code of 200 or OK to the requester. So now moving on to the second route, it's going to be that second line of code, router.get. This route responds to GET requests with a specific ID parameter in the URL. It accesses the same accounts collection in the database. It constructs a query to find a specific document by its ID field, using the value passed in the URL parameter recparams.id. The ID is typically a unique identifier for each document in MongoDB. The find_one method is used to search for a single document that matches the provided ID. If a matching document is found, it sends a document as a response with a status code of 200. If no document is found, it sends back a not found message with a status code of 404 not found. And that basically wraps up part 2 of the full stack banking application. Make sure you check out the next video. I'll be covering the actual deployment and a demo of the app. So I'll actually show the app working in real time, and I'll go over some of the features I added and some of the UI design decisions I made. Thank you guys so much for watching. I'll see you in the next video.